All right, this entire unit I kept saying wait till we had to start graphing this, and this is where we're going to start graphing polynomials in standard form. So when we want to graph polynomials, there are 4 things we need to look at. The first thing, or one of the first things we look at, is the degree. So I'm going to go ahead and tell you if the degree is even, then that means the ends will match. If the degree is odd, then the ends will be opposite, will face opposite directions. The leading coefficient, if the leading coefficient is positive, then I know that the right side of my graph will point up. If it is negative, then the right side of my graph will point down. So when I talk about end behaviors, that's where we're looking at the degree and the leading coefficient. So we can figure out what the ends of the polynomial are doing just by looking at the very first term. X-intercepts is what we've been practicing all week. To find our x-intercepts, it's the same as our solutions. So we either factor using the star or factor by grouping. If we cannot factor it, that's where we have to use P over Q in synthetic division. So again, since we've been back from break, we have done nothing but find the x-intercepts of a bunch of different polynomials. So we're going to apply all of that in step 3. For step 4, I want to find something called the relative minimums or maximums. So the relative minimums or maximums always occur halfway between each x-intercept. There's 2 ways to find that. So the x value is the halfway between each x-intercept. The y value you can find through either substituting x into the equation and just plugging into a calculator, or you can use it finding synthetic division. I will show you all synthetic division since that's probably the one we're least familiar with. If on the try your own you would rather substitute into the equation, you can totally do that. So the one example I'm going to do for you is negative x to the third plus 4x squared plus 4x minus 16. For this problem, the first thing I'm going to actually look at is my leading coefficient. I see that the leading coefficient is negative 1. And in the notes we took before, if the leading coefficient is negative, that tells me that the right side of my graph is going to point down. The degree is 3, which is odd. So that tells me that my ends will face opposite directions. So once I have my ends, I need to know where they go, so I have to find my x-intercepts. If I look at negative x to the third plus 4x squared plus 4x minus 16, I'm going to first always try factoring. Since there's 4 terms, I'm going to do factor by grouping, but first, my first term cannot be negative. That should be a minus 4x squared minus 4x plus 16. So I'm going to split it in half. My first 2 terms have x squared in common, so that leaves me with x minus 4. My last 2 terms, I can pull a negative 4 out, so that also leaves me with x minus 4. So this can be solved through factoring. So I'm going to set up, I have negative 1. I'm taking x squared minus 4, and I'm multiplying that to x minus 4. This will break down into x plus 2, x minus 2, and then x minus 4. So I'm going to take my 3 factors. I don't have to worry about the GCF because there's no x with it. So I just have to take x plus 2 and set it equal to 0, x minus 2, and x minus 4. So my answers will be x equals negative 2, x equals positive 2, and x equals 4. So again, these are my 3 x-intercepts. So I'm going to go ahead and graph those. I have a -2, +2, and 4. So we have our leading coefficient and our degree. The leading coefficient tells me that the right side of my graph, so I'm going to start at the most right x-intercept, and I know that the end of that graph is going to point down. It's going to keep going down forever. Because my degree is odd, that means the left side of my graph is going to do the opposite. So that's how we tell the end behaviors. To figure out what's going on in the middle, in between all the x-intercepts, that's where you use step number 4, where I said take the halfway points. So I'm going to mark my halfway points in red. So I know this is a halfway point, and this is a halfway point. So like I said, I'm going to show you guys how to find this using synthetic division. My first halfway point, where my relative min or max is when x equals 0. So I'm going to use synthetic division to figure out what the y value is there. Which is -16. Because remember, your remainder is always your y value. So I'm actually going to count by 2's on my graph. This is kind of hard for me to mark, so I'm just going to mark that that's -20, and that up here is +20. Now I only counted by 1's on my x-axis, so I need to make sure that I mark that. So I just put a 1 there for the first one. Okay, -16, so that'll be down here. My other relative maximum is going to occur at 3. -16 and 21 is 5. So 5, if I'm counting by 2's, will be halfway between 4 and 6. It's really hard for me to do on this pen. So from there, I just need to connect the dots. So I just need to go from my x-intercept down to -16, up to my x-intercept, up to 5, and then to connect my last x-intercept. So that's how you graph your polynomial. So for the try on your own, it's the same thing. Start by looking at your leading coefficient and your degree. I'm going to go ahead and show you. If you try factor by grouping, you'll have x minus 2, and here they only have a -1 in common, so that's 5x minus 6. So this will not use factor by grouping, which means you have to do p over q in synthetic division. Good luck.